Hello everyone, I'll be introducing our new tool, Drivora, a unified and extensible infrastructure for search-based autonomous driving testing. We first introduce our tool design. An autonomous driving system is an intelligent system that controls vehicles without human intervention. It perceives the environment through sensors and makes driving decisions accordingly. Simulation-based testing, especially search-based testing, has become a mainstream way to ensure ADS safety and reliability. But here's the problem. Different approaches use different scenario definitions, different simulators, and different ADS. That makes it really hard to reuse testing methods in a unified way. Especially some platforms have been sunset. Moving across platforms takes a lot of effort, and as the number of ADS keeps growing, it's even harder for new researchers who are just getting started. That's why we need a unified, easy-to-extend ADS testing platform. Carla is now the most widely used simulator for ADS evaluation, and our tool is also built on top of it. Recently, some works have tried to build unified evaluation platforms for testing different ADS. But here's the issue. Most of them still rely on handcrafted static scenarios. That makes it really hard to extend and support different testing methods. Another problem is that these platforms usually support only single ADS setups, meaning just one autonomous vehicle is controlled by the ADS under test. This makes it hard to handle multi-ADS scenarios, like when multiple autonomous vehicles interact. And finally, the way scenarios are executed is often sequential, one scenario at a time. This leads to underutilization of hardware resources and reduces efficiency, which is especially important for search-based ADS testing. To address these limitations and to provide an easy-to-use ADS testing infrastructure, we present our tool, Drivora. Specifically, as shown in Table 2, Drivora first adopts a unified scenario definition based on low-level actionable parameters. The figure on the right shows the corresponding code. This definition is compatible with existing ADS testing techniques and can be easily extended with user-specific customizations. Based on OpenScenario, Drivora is designed as a unified search-based testing platform. It consists of three main components. First, ADS and map integration combines different ADS and seed scenarios, providing the initial resources required for testing. Second, the testing engine follows a modular evolutionary design, which includes scenario mutation, scenario execution, testing oracles, testing feedback, and scenario selection. Each of these modules can be customized and extended to support different testing strategies. Scenario execution takes a concrete scenario configuration as input and produces scenario observations. In Drivora, this execution not only supports parallel runs but also handles scenarios involving multiple autonomous vehicles. Next, we will present a demo to introduce how our tool is used. Our tool currently supports 12 different ADS, covering module-based, end-to-end, and vision language-based systems. It also supports 6 different search-based testing methods. Our tool is publicly available on GitHub with a detailed README for usage. We provide easy setup scripts for different ADS and testing methods. Assume you have already set up the prerequisite. We're showing installing ADS Roach with the random search method. All you need to do is run the install.sh script, and it'll take care of the whole testing environment setup. Once the installation is done, you'll notice a new Conda environment has been set up. Next, we need to generate seed scenarios. You can handcraft them if you like, but we also provide scripts that do it for you. In this demo, we'll show the automatic way. For example, by running this command, you'll get 10 seed scenarios in Town 01. Each scenario comes with an ego task and a route length between 50 and 100 meters. You can then find all the generated files in the Scenario Datasets folder. Once everything's ready, you can jump right into testing. We've included a demo script so you can quickly try out Roach with random search. In this demo, we set the parallel number to 4. That means the search runs in parallel with 4 execution instances. As shown in the demo video, once we start the test, 4 execution instances are automatically launched, and the search process kicks off. We'll skip the rest of the run here since it takes quite a while. If you'd like to try more, you can find extra execution scripts in the scripts folder, and it's easy to tweak the configurations there. Here, we present some qualitative results to show that our tool can detect violations in ADS. Here, we show how to view the result. Each run generates an overview.json, where you can check the detected violations and localize the corresponding scenarios. For each scenario execution, both trajectory visualizations and video recordings are saved. You can download the videos and view them locally. We are showing some interesting cases discovered by using Drivora. These 2 videos illustrate collisions of the ADS under test. In the left video, the AV accelerates competitively against other vehicles, resulting in a side collision at a junction. In the right video, the AV fails to make the correct deceleration decision when encountering an NPC vehicle. This case shows a vision, language-based ADS misinterpreting a speed limit sign as a stop sign, which leads to prolonged immobility. Our tool supports testing ADSs with multiple autonomous vehicles. These two cases show that it can uncover new issues in multi-vehicle traffic scenarios, for example, gridlocks caused when several vehicles are controlled by the same ADS. In conclusion, we are the first to propose a unified and extensible infrastructure for search-based autonomous driving testing. Our goal is to contribute to the software engineering community in the area of ADS testing. For more details and tutorials, please visit our GitHub page. Thank you.